So let's get started. So now before moving on to any of the topics, I have something to speak about. So yesterday we were working with one file called employee projects, and we had made some charts, basically pivots, and there was a question for this particular place, and the solution is quite easy and understandable also. So yesterday we had made a chart based on this particular scenario. Now the question was like, if I just wanted to check for years, and I don't want separate bars for all of them. I would rather take all of these particular options in one bar. So I should only get 4 bars, or rather 4 columns. And each of those columns should be segregated based on the numbers. So how is that possible? So that was the question yesterday. So I've found a solution to it. So it's a very simple solution. So this was the regular column chart, which is based on this pivot table. So what we can do, we can just keep it minimized somewhere. Uh, uh, are you able to hear me all? Is the video and audio fine? Please check. Anybody facing any issues? Okay, video, audio, both are fine. So Amit, I would just request you to just check the audio settings or disconnect and reconnect once again if you are using any headphone. So look into the icon and then check the sound devices also, whether it is configured or not. So people are able to hear me. Just check your audio settings. Okay, so for your benefit, we are also recording this particular session. So once we finish this particular part of these modules, for further reference, you will be sent the links to view the videos as well. So let's just talk about the solution that we have. So what we have to do, we just need to do a little modification in this particular pivot itself. So this pivot, if we simply take it here, so automatically you see that there's a change in my pivot chart. So what I have done, I have just formed a cross tab, um, just taking the months. So taking the months were here. So taking the months in this particular place. So it makes us a cross tab chart or a pivot. So look into this once again. So what I have done, carefully just take this higher date. We could have done the other way around also, taking the months here and then years over here. So both are absolutely fine. Yes, absolutely. So just check with the sound settings in case anybody is having any issues. So connectivity and the sound settings, just check that. It should be absolutely fine. And it is fine with all other participants. So just check anybody who is having any issues with the video or audio. Just try to check the settings. So just check from here, go to this control panel. In control panel, you will see something called hardware and sound. So just go to sound and see what your manage audio says. So for me, it is a headphone as a speaker or the playback. And for recording also, I'm using an external mic, which is actually a part of the headphone itself. So just check whether See, as I'm talking, you can see the bar. This means that the mic system is absolutely fine from this end. And just to have a look at this particular sound checks and all, just check, test your sound, and once again come back to this particular place. So just check with your control panel first, okay, and see whether this should not be muted or something like this. So have a look. Okay, so what of the thing that we were discussing is that first of all, what you need to do, just take your hiring date over here, and you will see that it has changed to columns, different columns. Now, what we need to do, we need to simply go to our design option, and there's an option called change chart type. If you go to change chart type, you will see the next one is a stacked column. So the moment you click on stacked column and say OK, you will see that automatically your chart has been converted, and you can see all the bars one above another. So this is what we wanted to show you. This is just an example. So altogether, you can just say that so because if you are talking about a regular column, it is very difficult to understand which year has given us the maximum hiring and all. So this particular chart gives us a very good way of looking into this kind of data. So instantly you can say that 2013 most of the hirings were done, and 2011 and 12 almost like regular hirings were done. And in if you just click here, or please check the audio, Amit. So there is no problem from the side. Just check once the control panel, or if you are using any other browser, I would request you to use Firefox. So in case the other browser is giving any issues. So so okay. So just check how it works, and if you have missed a part of this particular session, don't worry, we already are in a recording mode, so you will be able to connect, and then you will be able to understand these things in case you have any issues. Okay, so let's proceed. So we have this particular chart. So this was the question that was asked yesterday, and just to give you a heads up, this is what the answer should be. So let's move on to today's topic. So before moving on to this particular topic, let me explain. Welcome. So let me explain this one part which was on Spark lines. This is a very interesting thing. I will tell you the story about this particular topic also. In your data set, there are a couple of files that has been downloaded from big data servers as well. So one is your World Bank indicators, so that you can use for any kind of analysis that you want to do. This is a real data for past, I think 8 to 10 years data is there. So it talks about all GDP, population, per capita income of the of some of the cities. So there are hundred thousands of cities. So we could only download a few because it's a huge database. So still it is a part of the big data, so which is manageable in Excel. So just whenever you have time, go through this World Bank indicators. This is a very good data. So and you can see that it's in CSV format. So CSV format means that your data will not have any formatting or other things. So it will be just as a comma separated value. Now, apart from this World Bank indicators, I also have got something very interesting, because to show you the spark lines properly, I required a huge database which is spreading into years. So I found one database, something like that, and I have passed on to you as a part of this data set. So you may have a look at this particular data. So the file name is baby names. If you open this baby names, I will tell you what is this all about. First of all, this is a CSV file, which means that it cannot store any graphics, any pivots or charts or all other things. Now, what is this all about? So you can see there are three columns predominantly. So we have year, we have name, and we have frequency. So if you talk about any of these rows, I will just tell you what is this. This is a part of census that was conducted in one of the province of Canada, which is Ontario. And this was a census done for female child. And this is what the output is. So this is the like what you say the census data is all about. So if you just look into one of the rows, it says, suppose if you talk about this particular row, it means that in the year 2005, this name Alia was chosen by 7 parents. This is what it means actually. So the frequency, the name, and the year. These three things are there. Now we want to do some analysis and we want to find some trend, which is some interesting trend. So this was a huge database, believe me, and I have just extracted some of just a nominal thing from that particular database. And still, if I just go down, if I just press control and down arrow, if I go down, still it is almost around 83,000 records. So I have taken some around 90 years of data and all the possible names that we could find in that database for babies, female child in Ontario. So we have just got that for you. So you can do some very good, interesting analytics over there. So let me just show you some of the things. So first thing, if you get this kind of data and if you see that some heading, I mean to say some description and all those things are there at the top. So first of all, remove this. So this is not required actually. That was just for like whenever we download data at some time what happened, they put some description about the data. So that was that row. So we can remove that. And let's begin our journey with this particular file. So what we will do, we'll take our cursor to the first uh, row and first column, A1 cell. And then from our keyboard, if you simply press Control Shift right arrow down arrow, you will see that the entire 83,000 records have been selected. Now what to do with this particular data? The first thing first that we have to do is to convert this to a pivot to understand what is this data all about and what kind of information can this data give us. So for that, what we will do, we will be simply taking a pivot and then when the pivot comes, you say display and classic pivot and say okay. This is the same thing that we did for other pivots as well. And this is your file. Okay. Okay. So now what happens when you have got the pivot? The first thing that I would like to know about this particular data is, see, I have got the year, I have got the name, and I've got the frequency. The minimum thing that we can do from this particular data is to find out the female child population of this particular province. So how do we do it? So we simply say year. So year comes here. And then what we can do, we can just talk about the frequency. The moment we talk about the frequency, it comes like this. So it comes as count of frequency. So now this means that 1917, 456, 472, this data is not looking correct to me. Why? Because it is not possible that every year this 400, 500 kids were born in that particular area, in that particular province. So something is wrong in this particular pivot that we are making. The issue that is there in this particular table or this particular pivot table, anybody who can just think of what is the probable solution, what we can do to get the exact population for this particular year. So anybody who can give me an answer that what is the problem with the pivot. So it is showing something like 456, 472, which I think it is not the output that we are looking for. So we are looking for something like the trend of population for this particular years. So from 1917, if you go down, you will see that the year goes till 2010. So 1917 till 2010. So you can see here almost around 94 years data is there. So now the problem here is frequency here is as a count. So count of frequency means that in our case in 1917 456 names were used by parents. That is what it means. But it does not give the exact number of how was the population. So for getting that population, what we have to do, not the count, we have to double click and say here. So just double click on that count part. Absolutely right. So you simply say sum. So thanks Archana for the answer. So we have to just take sum and say okay. The moment we take the sum and say okay, we now see the population. So the population of each year has appeared over here, which is absolutely correct way of looking into this data. Now a small thing we need to do. Now we are not so good at crunching numbers. So if I just by seeing 95 years of data, I can't tell what is the trend of population in that particular province. So the simplest and easiest thing that we can do for this particular data is to make a chart. Now, anybody who can suggest me what type of chart we can make out of this particular data? We have seen some column charts, we have seen pie charts, line charts, and bar charts, and so many charts we have seen. Anybody? We have almost around 90 plus data points, and we wanted to make a trend line, or we want to make it make a chart out of this particular data. So, what kind of chart would you suggest? So, better to say, what kind of histogram would you suggest? So, these terms are known as histogram primarily. So, let's see. So now this particular frequency, which is used here. So, if you just wanted to make a chart, you go to this chart and say pivot chart. And from pivot chart, see it is showing as clustered column or the column chart. We can actually use this particular chart as well, what is being recommended by Excel, or we can use the line chart as well. Both of them are fine. So let me take this column chart and see how it is looking like. So instantly we can just have a look at the like the growth of population. So we can see that if you simply do like this, it expands. So you can see here that some of the data points are going up. So this means that from this 1935, 41, 40s to 1960s, there was a tremendous growth in population in this particular area. So this means that if that was the case, so 60s So 1940s to 1960s, this means in today's date, people who are almost around, those people are almost around for maybe in their 40s to 60s. So they are almost in that old, like the towards senior citizenship space. So 60 years. So most of the people who where the population trend went high, those people are now in their 50s and 60s and 40s. So something like this. Okay. So we can just do some analysis. So if we there are so many things that we can do. So let's say we can check whether any kind of disease or issues were found in this particular time period or not. Or let's say when we saw a dip in the population, was there any specific reason for this dip? So we can analyze that. So we can deep dive and see how was the other factors as well. How was health factors in that particular time. So if we found that okay, there was some health issues that were found in this particular period, so what we can do, we can actually do some promotional activities, some healthcare related things for old age people, because we know that these people are now in their 50s and 60s. So we can do some healthcare promotions. So we can do some activities and some awareness programs for elderly people for this particular area. So these are some of the things, some of the actions that we can take just by from a simple frequency, from a simple population chart. This is how we can make some predictions or some analysis or some results we can draw from this particular data. So this was just a glimpse of it. So now this was one thing. We had made a chart. Now the next thing that we are heading towards is we want to know not the trend of the population. This we have seen. So right now it is a steady growth or steady population every year. So I'm talking about 5 years past. So if we just remove this particular chart and we are interested in something else. Something else means that we wanted to find out which name is the most popular name. So I don't want the year this time. So if I just bring in the name here, see what happens. It gives me all the names. Now, if I wanted to find out the most popular name, what I have to do, I have to just come to total and then just take your cursor to any one of these cells and simply say Z2A. The moment you say Z2A, automatically you can see that you get the top name at the top. So Mary and Mary. So these names were actually the most popular names. So whatever 90 years data we have got, so we just found out the most popular names. Now we just wanted to find out these popular names, whatever we find in this top 5 or top 10 list, if you take, are they still popular or they have lost their popularity? Is any name coming up as a most popular name in this particular region? So those all small interesting analytics we can do with Excel for this kind of data. Let's have a deep look at this particular data. So right now I can see that okay, fine, the most popular name is this. Now what we can do, we can play some tricks here. So this year, what we will do, we will bring it here. The moment we leave this year over here, it will just take some time because it is 90 years of data. So automatically you can see that the names are here and the numbers are here. So I can see that, see a particular name, how was the trend, we can see here. Now I find something very interesting. This name Jennifer, or if you talk about the name Karen or Jessica, these names were not there from the beginning. Fine. And still they are in the top 10 or top 5 list. How is that possible? Again, if you talk about this this Margaret name, you can see it was such a popular name when we started off this particular census in 1917, but it has lost its popularity. slowly you can see it gain popularity, and so slowly it reduced, the popularity was reduced. So we find some interesting facts and figures over here, and our objective is, like, there are two objectives mainly. The first objective is to find out how is the trend, and are the top names losing popularity or gaining popularity, or that kind of thing. And how, what about these names like Jennifer, how exactly or from when exactly they gained popularity, and something like this. So those kind of insights, if you want to gather, we have to take help of some of the advanced features of Excel, which is a very interesting part of Excel. So let's look into this. So since it is a big huge data set, so and we want to play with the pivots, so what we can do, we can just we have already got the main data what we wanted across tab view. Now I don't require the pivot anymore. So understand one thing, how to remove the pivot. To remove the pivot, just click on this corner cell, and then anywhere just right click and say format cells. Sorry, just copy this and right click and say paste values. So now what happens, automatically your pivot table goes off. So it is not there anymore. Now what we will do, the most interesting part of this particular section. So let's see. So first of all, what you need to do, we are actually heading towards making some small charts of, let's say, what we call it, miniature charts we are looking for. So let's have a look. So what we will do, we just increase this bit, increase this particular bit, watch it carefully, and we'll take some rows, some random rows from the top we are taking, because we wanted to see the trend line, and we make some space like this. So just for you to understand this, this is not mandatory that you have to make such a big space or something like this. This is just for your benefit, just to make you understand. So first of all, what we need to do, just take your cursor to the first row, and then there is an option in insert, not the charts. Besides charts, there is another option called spark lines. Just click on the spark lines, and there's an option called line. Just click on that line, and you will find something called data range. So data range, if you see, this data range is actually from this area. So it is asking for data range and location range. Location range it has already taken. Wherever we had kept the cursor, it has already taken the location range. Data range it is asking for. So data range is actually from this part, and if you just press Control Shift and left arrow, it will select the entire data, and then you just press Shift and right arrow. So our objective is to only take the data part, not the name and not the total, the grand total, because it will skew the data. And the moment I say OK, you will, if you scroll to the right side, you will see something very interesting. So this is a chart, but this particular chart is within a cell. So Excel allows you to prepare charts as a part of, you can use them as for dashboards also. Some queries are there. So that thing also we can check. So like if you have a dashboard and some KPIs and all, so that thing you can actually work it out here. And now what we are doing, we are just like your Control C, Control V. I'm just putting it like this. Wait, Control D. So if you simply say Control D, you see that these all charts are filled. So automatically you can see, you can just uh, take this particular charts as much as you want like this and look into this particular chart and tell the story about this. So the first story that we can tell about this particular charts is about this first name called Mary or Mary. So both of the names were simultaneously used and they took a peak in the 20s when we started, when the data was collected mainly, and gradually it has lost its charm. So that name is not used so often. So it is like diminishing. So you can say that the trend line over here. Now there is some interesting thing about this Jennifer. This Jennifer name was not there since beginning. So it came almost around, let's say, 30, 40 years, 30 years almost like that. And then eventually it took like a steep increment, you can say. And then again it is diminishing. So our objective here is to find out which name, if all these names are losing popularity, which name is gaining popularity. So we can see this particular chart. This is something interesting. This particular name is gaining popularity like anything. So if you just scroll towards the left, we wanted to find out which is this name, which was not there since the beginning. So in 1920s, 30s, 40s, this name was not there. And slowly, so this name is Olivia. So this name actually came in as a steady growth from this particular year. So we'll see which year is this. So almost in the 1970s, it came as a popular name, and then it is having a steep, it is showing a steep growth over here. So this is the popular name we can see here. Similarly, there might be other popular names as well. So if you talk about this particular name, so we can see this name is actually Audrey, which is gaining popularity. So it gained popularity in the 20s, then it lost the popularity eventually. And then it is again gaining popularity right now. So what we can do, we can just by creating, because crunching numbers, we are not so good at crunching numbers. So just by seeing the numbers, we won't be able to draw some conclusion. But by just creating some miniature charts, now creating charts for such a huge number of names, it was not possible in Excel, regular Excel. So making charts and then line charts or column charts, not feasible. We wanted something very innovative, and then so that we can just within a particular place itself, we can find out what is the output and we can talk about that, comment about that. So Sparklines gives the absolute uh, like answer for that kind of situations. So now there are multiple things that we can do for this Sparkline. So if you just go to design, we can change it to a column also. So this is how it looks like. We can change the colors as well. That is also possible. And something very interesting, just like your stock market. So this chart looks like your stock market, right? So stock market charts. So if you have any stock market data also and you want to do some analysis, some real-time analysis of how things are going on and where to invest and all those stuffs, then Excel, this particular facility can help you there also. If you simply go and click on that high point, there's an option called high point and there's an option called low point. So high point and low point. So in terms of trading, in terms of, let's say, when we are seeing intraday tradings and all, so we definitely would like to see the high points and low points for the particular day. So this Sparkline gives us a very good way of taking those options over here. So We can change the color. We can do something called first point, last point, where it started, where it is the last point. So those all things we can put within the chart. So it's a miniature chart which has got uh, great application. So we can create different types of charts. So see here how the charts are looking like if you make it bigger. So this is all about your spark lines. We can use them for dashboarding purpose also. This was just a demo to show you what is the exact use and how it can be used. And for let's say any kind of data which is rolling to months or days, we can show a spark line within that. So let's take an example. If you want to show some quality parameters or some, let's say, KPI parameters for your team or for your organization, for your department, then this spark lines can help you. So let's say the sales figures, uh, like person wise sales figure or something like this, something where you have multiple data points and making a chart is not feasible. There this particular option can help you very much. Fine. So let's have a look. So now if you want to store these particular spark lines, then right now our file name is in CSV format. So what we can do, we can say save as, and wherever you want to save as. But when you are saving, save it as an Excel workbook. If you save it as an Excel workbook, then all these charts and all other things will be saved. So this was about the spark lines, which we could not finish yesterday. So now let's quickly move on to the next topic, today's topic. So first of all, we will be doing some very good hands-on, like I'll show you some of the terms and discuss that. So when we talk about analytics, so analytics is a huge term. So analytics is everywhere. So previously we say that when we started, we had the era of hardwares. So people were mad about hardwares. So supercomputers, microcomputers, mini computers, and all those computers came. And uh, gradually, what happens after the desktop came and the laptops came? So what happened? There was a that era went off. So there is no more craze about hardware now. Then after hardware, what happened? People who had invested in that hardware so much, they wanted to make use of that hardware. And then came the era of software. So people were mad about different types of software to be installed. Some were installed on the LAN environment, some were installed directly on standalone. Gradually LAN environment became popular and all other things happened. Then what after that software, so this software kept on generating data. So then your requirement for storing that data came into picture. So people were like again crazy about storage place. So storage, I remember, still remember, storage was a huge business, and it had given huge opportunities and other credibilities also. Now the data was stored for years. Now there are companies which have their data stored for decades now. So if you talk about, let's say, companies like IBM, they are storing data in, let's say, tape drives, and they run into kilometers below ground level and all those things. They have warehouses and other things. So there are like things what now what happened, people used to use tape drives, then came the hard disk, like I mean to say hard disk, and then CD and all other things, and now everything is a flash drive. Even CDs and all flash drives are now also diminishing. Everything is a chip, a small chip. That's it, your all data is there. So data is there everywhere. Now we have to understand why we have so much of data. And like we say that 95% of the data that we see today was generated in only past 2 years. fine. So billions of gigabytes or petabytes, zotobytes, octabytes. So many types of so many terms have arrived. So previously we used to only have kilobyte, megabyte, and gigabyte was a huge like big term for us. Now gigabyte nobody talks about. We have something called like moving back to that terabyte, petabyte, exabyte, zeobbyte, yottabyte, zotobyte. So these all terms have arrived now. So we, as we move forward, these some other new terms will also come to us, and we will see. So now we have so much of data. So now companies are saying that okay, fine. First of all, you said hardware, so we bought the hardware. Then after you said that to work with that hardware, we required software, so we invested on software. Now those software started generating data, so we had to store them, and we bought like storage services also. And now we have everything. Like today's scenario is that we have something called cloud technology also storing data and other things. Now they're asking what after this. Now we have got a huge amount of data. What to do? What is the use of such data? So we say that fine, what we can do. Still now we were just let's say doing some slicing and dicing of data and understanding the past. We call it descriptive analytics. Now Excel also to an extent supports something called predictive analytics. Predictive analytics means that based on your past, you can predict the future. So I won't say that all the functions and whatever functions are used here and that I will be demonstrating will be 100% accurate for forecasting and all other things. But you will definitely get a idea of that, like what are these terms known as. So what we will do, we'll take a small example to understand this analytics concept. So from your table, the first thing that we are going to take is this particular sample of data called Toy Story. So if you open Toy Story, it looks like a very simple database. So I'll tell you the story behind this particular data. So one of my friend is having this toy manufacturing unit. So he manufactured toys, and he has got a huge let's say, factory, and then so many workers are working there, supervisors, production heads, and all those people are there. Now that is a complete production line, operations and production line. So now one fine day he just walks to me. We were just discussing something that I do some analytics works as well for different organizations and all. So he said that why don't you do something similar for me? So I said what kind of things are you looking for? He said my requirement is very simple. I just wanted to find out that tomorrow or next month, if I put, let's say, 1,000 machine hours, how many products I will make? I said that this is nothing that it's something, it's not like some Akashvani or something that I can tell, okay, if next month you will be making so many objects or so many toys. It can't happen like that. So for this prediction to happen, I require some past data. So give me some past data. So he says that, see, we are not into IT or some sophisticated organization who keep their numbers and keep their data and all storage and all other things. I said, fine, you don't have such a huge data or data of each and every hour and minute and all those things. But can you just give me something like, let's say, at least month on month, if I say that how many products you have made and how many machine hours you have given? Will it be possible for you? He said, yes, that much data you can get. So what he does, next day he comes with this simple register and something like this. So he says that this is my data, and so brings a printout and says that in January month we had put only 167 machine hours, and the production was very low. So we had issues. So what I have done, I have just noted those machine hours and products. I said, okay, fine, we will convert it into Excel. So this is what the Excel format is. And then what he was talking about is, so I have just put it as a column over here. So if you open this file, you will see here, it is already giving this machine hours and products made. So what he is asking is, if I put 1000 machine hours, what will be my products? This is what the question is. So now that he has given me data for past 12 months, because 12 months, I won't say it's a very great data to talk about prediction and all, but at least it will give me some heads up. So what we will do, we will try to make some predictions over here. So watch it carefully. This is a very interesting, and just in a layman's term, I am making you understand what is predictive analytics. And believe me, Excel can do much more than this. So there are different analytics tool pack available in Excel. You can go through at your own time. I will show you where is the repository or where is that treasure of analytics in Excel. And today's Excel has the capability to connect to databases also. That also I will show you in the second half when we talk about the final module. There are interesting things at the end of the session I will talk about. So please don't miss that session as well. So your queries and all will come definitely when you see such good things in Excel happening. So coming on to the topic, so he just says, okay, 1000 hours, how many products we will make next month if I just put 1000 hours. I say, so okay, fine. So let's have a look at the data. Now understand one thing, whenever you want to do some predictions, whenever you want to do some forecasting, some terms you have to understand. So this is X. So you're saying that if you put X number of machine hours, what will be my Y number of products? So this is X and Y. So the more X you put, the more Y you get. So they are proportional actually, what we call in maths term, proportional. So directly proportional, better to say. So when X grows, Y also grows. X diminishes, Y also diminishes. Now, if this is X, we are talking about Y. So we say that, okay, we need three things. We just need something like the known X's and the known Y's. So this is my known X and this is my known Y. So my known X and known Y's have come, and now we are in the process of doing the forecasting. Now, before doing the forecasting, I just wanted to make sure whether forecasting is worth or not for this particular data. Is it worth? So how will you make sure? So what we will do, we actually create a trend line for this data. So let's have a look. How do we make a trend line? So for making trend line for any of the data points, you first of all select the data. So both X's and Y's should be selected. And after you have selected the data points, you simply insert a chart. So if you simply go to insert, and there's a special type of chart called scatter chart. So scatter chart is actually used for finding out correlation between data points. So if you simply click on this first option, you will see that there is a chart that has appeared on your screen. So it definitely gives me an idea that, okay, if I see that visually also, I can see that there is a upward trend, which is natural also. The more number of, this is your machine hours and this is your products made. So the more X you put, the more Y you get. This is the X axis, this is the Y axis. The more machine hours you put, the more products you get. Okay, so now one thing we have got. Now we wanted to find out before doing the prediction, how will be my prediction or how correct will be my prediction. So what we do for doing that particular thing, we need to bring out a trend line. Look at this carefully. How do we bring a trend line? So just these are known as observations. In terms of analytics, these are known as observations. And this is not a hi-fi thing. This is not a very complicated thing. A very simple, and I believe me, two or three examples of analysis, whatever we have discussed till now, those are very simple and yet very practical. So last time I remember, if we have shown you something called, just a second. Sorry. So In terms of analytics, so last time, if you remember, we had talked about the Pareto. So Pareto also had its own use in our day-to-day work. So Pareto actually is used for finding what we call it as a, let's say, 80-20 concept over there. So we wanted to find out the 80 and 20%. Here, this particular chart is actually used to find out how these dots are correlated. So is there any correlation between X and Y? So the first thing that we need to do is to find out, see, we need to make a line over here to understand. Now making a line by myself will not help here. So what we will do, we'll ask Excel to make a line, and that line is actually known as trend line. So what we will do, we will just right click on this particular observation, and we'll say format data series. The moment we say format data series, it comes up with this particular option, and we have the chart options here, the series option. So okay, before going to this format data series, you just right click and say something called add trend line. So format data series we will see later on. So first of all, you just say add trend line. The moment you say add trend line, you can see a dotted line has appeared. And what you do, you simply click on the last option which says display R squared value on chart, and then close this. Now let's understand what is this line all about. This line is actually called the trend line, and it is actually taken as a part, what we call it, the best fit. So there is an algorithm called best fit in analytics. So based on that, this particular line comes up. So it shows the distance between the line as well as the dots mainly. So we say that the more these dots are nearer to the line, the better is my data and the better will be my prediction. So here it says that, see, I'm not able to take this line and all doing some calculations. So Excel gives us a ready-made output. So it says that your data is actually 77.96% correlated. What that means? First of all, this is a positive number. So positive number means there is a good correlation. And there are two things we have to understand. This particular number that we are seeing, it can be minimum -1, it can be 0, or it can be +1. So these are the three. The scale goes from -1 to +1. This is what I mean to say here. Now, if it is +1, this means these dots are they are highly correlated. So now in our case, it is reaching 1. So it is actually 7.77. This means it is reaching 1. So you can say this 1 as 100% also, and this as -100%, and this as 0%. So this particular number 0.7796, it can be actually converted to a percentage, and that will be 77.96%. So this is how it is, 77.96%. So now what we say that these dots are 77.96% correlated. Now in other terms, what we can say, these particular dots, if you make a prediction that based on this particular dot, based on this particular data, if you make a prediction, then that prediction will be 77.96% correct. Now, how this 77.96% has come, we will talk about that also. There is some calculation that goes, some like arithmetic calculations that are there, statistical calculations. We'll not go deep into that, but just we'll try to understand those terms as well. Okay, okay, fine. I will show you how this R squared value has come. So R squared is actually the regression coefficient, and R's why it is squared, because you will see that if you talk about this line, some of the points are below the line and some of the points are above the line. So these lines will have plus and these lines will have negative. So if you like multiply both of them or add both of them, what will happen? It will come to 0. Fine. So to negate that particular thing, what has been done? It has been taken as the R squared value. How do we get that? We simply right click on any one of these points and then you say add trend line. So the moment you go to trend line, so this is what my trend line is. If you go to trend line, so this is what the screen comes. So at the end, just if you scroll down to the end, the last option says display R squared value on chart. So this is very important and this is very vital also to find out whether it is worth deep diving into this data or not. So anywhere, whenever you have got some X and Y, so if both are proportional or both are dependent on each other, the first thing that you need to do is to find out the correlation. So the moment you find out the correlation, and if you see that this number is approaching 100 or it is approaching 1, then you understand that it is having good correlation. So it is approaching 77%, 77.96. So definitely this is a good correlation, we will say. So now, based on this particular correlation, we would like to make some predictions. To make predictions, there is a very useful function in Excel called forecast. If you say equal to forecast, this forecast is a very useful function and it takes 3 parameters. The first parameter is X, means based on what you want to forecast. So I say that based on this X, I want to forecast. Then it shows your known Y's. Where are your Y's? So I know that these are my Y's, the products made. And then it is asking where are your X? So I say that these are my X. The moment I close my bracket and press enter, I get a number. Wow. So 31,291 products. So I can now go back to my friend and say that, okay, next month, if you put 1,000 hours, then you will get 31291 products. But hold on. Before saying this, before giving you high hopes, let's understand this number first, how this number has come and what this number tells you. So remember one thing, this data was not so good. So they are not so correlated. Why? Because you can, if you talk about this number, this name, this particular month, May, they had put 1760 hours and they have got 51,000 products. But in the month of November, they had put 1760 hours and they could make only 42,000 products. So somewhere it was 51,000, somewhere it was 42,000. So this was, we had inconsistency in the data. So now I have got the prediction in front of me, but I will say to my friend that hold on, this number is not accurate. This number is based on your past data, and this data shows that your prediction or the predictions that I have made is only 77% correct, 78% almost. So he says that I don't understand your terminologies, 78% correct or 77% correct. You tell me how many products I will make. I said, hold on, I will discuss, I will tell you. So to tell my friend how many products he can make, we have to do some very little calculation. So first of all, what you have to do, we have to find out the variance. What is variance? Variance is that, suppose I'm sure that this 31291 products will not be made. Either he will make less or he will make more. Now, how many products he will make less or how many products he will make more? So what is the variance? So the variance is decided by this particular 7796. So what we have to do, we have to find out what is the gap. So what is the gap? The gap is equal to 1 minus this. This is the gap, right? So 22.04%. So 22.04% is the gap for this. So they are not 100% correlated. So there is a gap of 22% in my data. So which means that there will be a variance of 22% for whatever predictions I am making. So let's find out what is that number, or what is the number of that variance actually. So the variance is, if you say equal to, we have to find out 22% of this number. So into 22%. If I click and if I press, I can see that I get a number like this. 6897 is the number. So what this means? This means that there is a chance that if he puts 1000 working hours, then he will have a variation of 6897 products from this number. So he will either make 6000 less products or he will make 6000 more products. So it will be in a range. So my friend says, okay, yes, this is what I want. So can you tell me that based on my past 12 months data, how many minimum products I can make? Because I will be talking about the warehousing also, right? So I need place for storing these products also. So I should have a place to store these many products. That's why I'm asking that if I put 1000 work, because we are planning to put 1000 machine hours as a target next month. So if I put that, how many products we will make, minimum and maximum? So we say that, okay, let's talk about the lower limit and let's talk about the upper limit. So what is lower limit and upper limit? If you simply reduce this variance from this total products, this minus this, and if you simply add this to the variance, see, so easy. So this being the middle, or this being the center of these two numbers. So now what happens is, you can easily say that based on, so the sentence should be like this. Based on your past 1 year data, it shows that next month, if you put 1000 machine hours, you will minimum produce 24,000 products and maximum you will produce 38,000 products. So this is the entire sentence that we can make once the prediction is done. Now we are keen to know what is behind this forecast. So how Excel was able to do this forecasting? What is the main technique behind doing this forecast? So forecast is done basis of function, basis of formula. So it says y equal to mx plus b, where m and b both are constants. So mx and b. So this is a equation of linear regression. There are different types of regressions. I say that by linear regression, this is getting the prediction of 77%. We might go for exponential regression, logarithmic regression to find out which one suits better. Fine. So it's not that linear regression is the end of analytics. This is just the beginning of analytics. So this is in the form of y equal to mx plus b. So what is m? M is actually the slope. This slope. How do we get the slope? See here. This is called slope. Just a moment. So this is your slope. So if I just put it like this for any data point, so if I just map it to any data point like this, so let me just remove the fill and change the color without any fill. So now you can see here if we, let's say, this particular data point. So for this particular data point, this is the slope. So slope angle we can see, and the slope distance and all those things are taken care of. This is the slope, and the second parameter B is actually known as intercept. Fine. So a point where, let's say, if we just minimize these things, where it will meet actually. So these are some analytics terms, so it won't be possible for me to explain all the terms over here. But just for your knowledge, just you understand that the equation is y equal to mx plus b. And if you want to show the same equation right on this particular chart, we can simply right click and say format trend line. And if you go down, you will see there is an option called display equation on chart. If you click there and cross it, you can see that the same equation has arrived here. So this is in the format of mx plus b, where b is negative. That's why it is coming as minus like this. So in this particular equation, if you put our 1000 as x and multiply this and subtract this, you will get the same output. See here, if I just come here, or let's say here, if I come and if you say equal to 40.92, which is my slope, and multiplied by 1000, which is my product, and if you say minus 9629, which is my intercept, 9629.1, if I just press enter, I can see that this number and this number are absolutely accurate and same. So whatever forecast has done, forecast has used the linear regression method, and it has calculated the intercept and the slope. So there are functions like intercept and slope also. So that also you can find out. So many functions are there. You can see the statistical functions and see them. Talking about the scope of this particular module, just understand that it is possible for Excel to do some preliminary analytics and forecasting. So this is just an example of that. So this was one example of forecasting. So we have discussed so many things in this particular topic. So I will just now, what I will do, I will give you one more example, which is somewhat again some real life example. So I just close this and I open a file called ice cream juice parlor. This is a very interesting thing. So your X and Y need not be only static numbers from your data. So let me tell you about this particular option. What is this data all about? Now this is the data of ice cream store that is located in MG Road in Bangalore. Now they wanted some help from me. They said that we know that if the temperature of Bangalore soars or goes high, then we have a good sale of ice creams. So people come out, they visit, let's say the malls and other places. Brigade Road is nearby, and they come to our ice cream parlor and they take ice creams. So our sales goes high. If the temperature is low, so we have seen some dip in the sales. We know that also logically. The higher the temperature, the more will be the ice cream or juice and all those sales and other things. People want to keep them cool using these particular options. Now he asked me a very strange question. Can you show me this relation? So we all know that temperature is related to sales in case of ice cream sales or something like this. Can you show me this relation? I said, okay, fine. We can talk about that relation. Definitely, we can show this relation. So what he did, he gave me is daily sales for a month. So last year, this is I'm talking about last year's thing. So for the month of May, so he said, okay, let's do one thing. Month of May, which has got some high temperatures also, and there was some rainfall also. So some reduction in temperature was also there. So can you show me that correlation? Whether temperature of Bangalore has got anything to do with the total sales or the sales of ice creams or juices. So I took up that particular activity and then I said, fine, okay. So for doing any type of correlation, you need two types of data. So one will be X and one will be Y. So here also we say that Y is dependent on X. So what is X? X is temperature and Y is the sales. We say that we want to find out whether temperature has any role to play for the sales. So both of them are X and Y. We want to find out the correlation. So simply what we do, we go to, so what I said that, okay, fine, you give me the data, your daily sales, and from the website, I collected the daily temperature of May month. Just the average temperature we can say for the May month for all these days. So 1 month data I collected. So average temperature in Celsius I have collected. Now I go back to the data. Now simply what we can do, we have to map this total sales with the data. So this first actually means 1st of May. And here also it means 1st of May. So 1st of May total sales has to be mapped with 1st of May temperature. So we can do a VLOOKUP or we can simply copy paste and then do like this. So what I have done this much for you, that I have just pasted the temperature in front of sales. So now this becomes my X and this becomes my Y. Always remember whatever is X, put it in front and then whatever is Y comes next. Now what happens if you select this particular data and this particular option over here. So both the columns we have selected. We are in the process of finding out what is the correlation between temperature and sales. So we simply go to insert and go to scatter chart and make a scatter chart. So this kind of scatter chart comes. So now we don't understand how to proceed with this. I can see a steep line. That's a very steep line that I can see here. So I am sure that there is a positive correlation. There's a very good correlation with this particular data. So now there are some modifications that we have to make. You can see that all the dots are clustered somewhere. And the temperature of Bangalore is showing as a scale of 0 to 40, which is not the case. Never it has gone to 0. So what we can do, we can just do some axis based changes. So we right click on this axis and say format axis, and format axis comes, and there what we do, let's say we know that minimum temperature will be 24 or something, so or let's say put it as 20 or 24. For May, the minimum temperature that we have recorded was 24 from the data. So if we do that, instantly we see that our chart has changed. So thanks to this format axis. So this is our data. This is our chart. And if we put it like this, this is how we get the chart. Now these are again the observations. So you can see there are 30 observations and it looks like a positive trend. Now we just want to make sure, what we will do, we will right click. We have done this in the past example also. Right click and simply say add trend line. The moment we add trend line, the same option comes here and it is asking for display R squared value. The moment I click here, but I'm shocked to see something here. We never expected that ice cream sales and temperature is 60% correlated. This 0.60 means 60% correlated. So I see some issues in this particular data. I'm sure that ice cream sales in Bangalore is not 60% correlated to the temperature. It's more than that. So what is the problem? So now what happens when you are not satisfied with this kind of data? So we need to deep dive and try to find out whether there are any issues or not. So right now, if I see my data, I definitely sense some issues over here. So look at these two data points. These two data points are actually far away from these lines or the trend line. So though this is the best fit method, still we see that there's a huge gap for this particular two data points. So here I can see that though the temperature was so less, like almost around 27 degrees centigrade, but the sales went up to 10,000, almost like that. And here the opposite thing has happened. So the temperature was soaring high, like 32 degrees centigrade, and still the sale was below 4,000. So these are known as outliers. So they are actually hampering my data analysis, and they have to be treated. So if you have a huge number of outliers, then you can treat them. You can actually put them into a separate scale and then see whether there is any correlation between these outliers or not. But if there are few, let's say 1 or 2 data points like this, whatever you are seeing, then we can treat them separately. Outliers should not be a part of your analysis. Your regular analysis, whatever you are doing, the objective of doing this analysis and the objective of making this scatter chart is to find out the outliers, because from this simple data, it was not possible to gauge who are the outliers. The moment I do this chart, automatically these two numbers are out of this focus. And we know that these are the two outliers. So what happens is that I try to find out which are these dates and which are these points. So there is no direct way to find out or click and then see which are these dates. So what we can do, we can just take our cursor, and then we see that there is a point wherein the temperature is 27 and the sales was almost 10,000. So we try to find out where is that particular place. So we see that this is my data. So this is the problem. Problem number one we have find out. So May 19th, 27 was the temperature and the sales went to almost 10,000, which is a reverse case. Usually that doesn't happen. And if you go to the other dot, it says that the temperature was 32. However, the sales was only 3,000 something. So we just find out, okay, we scroll and we see that this is the point, 32, and then the number is 2 less. So I immediately find out the two outliers for my data. Now the question arises how to treat them. Since these are only two outliers from a 30 data point stream, definitely we have to remove this. If we actually want to find out that whether ice cream sales has anything to do with the temperature or temperature has anything to do with the ice cream sales, then we have to identify and remove these outliers. But before removing these outliers, we need to ask that person, okay, can you tell me, or from your daily observations, can you tell me what happened in these 2 days? Why these extreme cases we are finding here? So he recollects. He says that, yes, in this May 19th, I remember. So there was an IPL match in stadium, and our ice cream shop is nearby itself. So we recorded a bumper sale on that particular day. So I said, fine, very good news. You recorded a bumper sale, but for my analysis, I cannot take that because that was an exception. If that IPL match was not there, your sale would have been regular. So because that particular match is affecting my analysis, so we have to remove that one point. So that is one thing. I said, okay, fine, we will remove this. Identified and we'll remove this. And then he says, okay, if I remove this particular point of IPL match, what happens? Immediately I see that my correlation increases. It goes to 77%. So outlier removed, analysis strong. Now again I ask, okay, fine, I see another outlier still now, which is not coming into my best fit analysis. So what happened on this particular day, May 4th? So he again checked with his people in that store, in that shop, and gave me the answer that yes, actually there was a strike or petrol bunker strike, something like this, that happened on this date. So though the temperature was high, people did not come out of their house in the evening also, and we had recorded a very less minimum sell on that particular day. So I said, fine, I'm sorry to hear that, but also I'm sorry to say that I cannot consider this data also for my analysis because this is also an outlier. So this was affected by a petrol bunker strike, not by temperature. So we have to remove that. So the process of analysis also has to deal with the outliers also. The main objective of any organization, any process, any department is to find out the outliers. And this is a very good tool, a very good way. So this is just a small chart. So you can see just like your line chart, pie chart and column chart, this is just a simple chart. But how you can gather insights from this simple chart is the most interesting and wonderful thing of Excel analysis over here. Sorry. So we say that, sorry, we can't use this data also, and we delete this. The moment we delete this, if it is a huge data, believe me, we will not delete them. We will put it in some other place. So to treat them, let's say I'm talking about some ice cream sales, you would be talking about some like team activities. So you see that in your team, the performance score, or let's say the quality score of 30 29 people or 28 people in your team has like, you see that the more tickets they have resolved, the better was their quality. So you see that the ticket to quality ratio was very good. You wanted to find out the trend. So you make similar kind of chart. Now you see that there were two people who were outliers. So one person was there who had handled so many tickets, but the quality score was very low. And there was one more person who had handled very less number of tickets, but the quality score was too high. So you cannot put them in the same category of others who are taking similar number of tickets and though maintaining their quality scores. So you see a trend line between them, and we can remove those outliers from there. So they will be somebody who is too good and somebody who is too bad has to be treated separately. This is what I mean to say. So we treat them separately. So the person who has taken random tickets and then recorded a very low quality, this means that the focus was not there and the parameters were not checked. So he was not complying to the rules and regulations of ticket resolution. So that's why the quality score went down. So we have to check. We have to give that person a training. And the person who had taken very less number of tickets and the quality score was very high, that's a usual thing. So we have to motivate that person to keep the score at that point and take some more tickets so that he gets at par with other people in the team. So this is how we actually work in quality analysis also, or in any type of KPI analysis or something like this. So this is a very helpful and useful tool. And then we say that, okay, fine, we now see a correlation of 89.15, which is a very good correlation. So now we can tell him that, yes, boss, I see that your ice cream sales and temperature of Bangalore are almost 90% correlated. So the higher the temperature, the better will be your ice cream sales. So this is 90% accurate. Fine. So if I make some forecast for next month or a day based on this, I can tell that, okay, if the temperature of Bangalore is this, then there is a chance that your sales will be this. So that kind of forecasting also we can do from this data. So some weird forecasting or some forecasting based on your regular data. So analysis can do anything. So if you have got the data, analysis will say that I have the answers for it. I can just explore your data and give you some insights out of it. Previously, what used to happen, the managers and the top level management, they had a very tough time. Like, they had to ask the reporting guys or the analyst questions. Okay, give me this data, give me that data. And there was so many hit and trials. So I said, okay, give me the KPI data, give me the ticket data, give me the quality data. So my intention is to find out the outliers, but I don't see anything in quality. So I say, okay, fine, quality is fine, give me something else. So they use hit and trial method in older days. Fine, management used to do hit and trial method to basically bring up the process properly. Now the situation has changed. Now the pivotal role is played by the analyst or the reporting guys. What they do, the approach is totally different now. they first give you a analysis, show the data. This is what the data is. And that data helps the management to ask questions. So the more data you have, the better will be your analysis, the better will be your output. Fine. So analysts now take a different approach. They show the data, management sees that data, and based on that, ask the questions. So always the questions will be meaningful. Time will be reduced because it is not a hit and trial method. It is actually going towards a direction, and definitely the resources are also used properly. So these are the benefits of using analytics in our day-to-day work. So this was a small example and a small understanding of how data works. So if you just, there is a sheet that is like we have unhide that sheet. And if you simply unhide that sheet, you will see this is how the analysis is done. So for the first place, we will not delete the data points. We will show that these two data points have, just a moment, please. some of the most important functions. So now it's getting recorded. So I had some issues with this thing. So past everything is recorded till the break. Everything is recorded. So now again I am recording this particular as a second part. So don't worry about this. Both of these things are recorded, and you will see all these things as a recorded module also. So don't worry about the recording part. So it is getting recorded right now. So great. So let's move get moving. So this was just an example of the analysis and equations and all other things. Just a very brief example of such a huge topic. So this was just a glimpse, and I hope that I was able to give you a small spark of what analytics is and how interesting this world is. So just for your knowledge, just for your work, so this is what we can do. So let's close this and go back to our module. So we have been talking about the terms R squared, slope, and all these things. And we have been talking about the how to draw a trend line, which is a very simple thing. So just right click on once you have got the scatter chart. Once you have got the observations on it, just right click on any of the observation and you can see the chart. Using Excel as the forecasting technique for regression and displaying the regression on equation on chart. So this was some of the very important things that we wanted to share. So now let's move on to some very simple examples of reporting and analysis, and we'll keep on moving and see how Excel 2013 or Excel 2010 or other Excel formats also or Excel versions also can give you similar kind of some good analysis factors. So let's see. If you go to this particular data set, I will just show you, just take a couple of minutes time of yours to explain something very interesting. So if you go to that employee projects that we were talking about yesterday, we had done some good charts, and then today also we made a bar chart and then stack chart and all those things. If you right click on any one of the sheets, you will find something called unhide. If you click on unhide, you will see that I have got some metadata, some other, actually whatever you see as the raw data of the employee project is a combination of all the different small tables. So there is an employee master table, there's a departments table, there's a projects table. So all of them were combined to make up that raw data. So if you click on that employee master and say, okay, you will see that this is the output that is there. So first name, last name, date of birth, contact number. So something we just wanted to do some instant work on this particular data. So what we will do, we will definitely like to work on, just a moment. So we'll definitely like to work on, suppose I'm just giving you a heads up. I just wanted to check what is the average tenuity or how is the tenuity of my employees. So this is the actual data of 30 employees that are there in my organization, suppose. So they have the hiring date, date of birth, and all these things are there. So I wanted to check the tenuity. So how tenuity is checked? Tenuity means from today's date, if you subtract the hiring date of that person, that gives you the month or year, whatever you want to take it. Fine. So let's take an example that based on months or based on years, I would like to take the tenuity. Let's take year. That will be better. How many years people are working in this organization? So I wanted to do something called bucketization. Bucketization is very useful concept in Excel, and that can be used as a very preliminary tool for doing some analysis. So we wanted to group our employees based on their seniority, let's say. So how to find out the seniority? First of all, what you can do, you can simply say that if you simply say equal to today minus hiring date. Remember, we were doing trying to do this in the calculation yesterday in that pivot. So same thing what we do here, if you just say minus, it gives us a number. So if you simply click like this, you can see that from today, almost 2003 days, this person, Jennifer, has worked for this organization. So now we are not interested in the days. We are more interested in the year. So what we can do, we can take the year of today, which will be 2015, minus year of the hiring date. So if you simply format this and format this, you will see now this is something very interesting. So 3 years, 2 years, 5 years, 4 years, something. So I see huge, like there are a number of years as a seniority. Now I can't do anything with these simple numbers. So I would like to bucketize them. So how do we bucketize? The approach is very simple. The way we had grouped our hiring date last session, in last module, the same way we will bucketize the seniority. Remember, we said that any data which has got numbers can be bucketized. Okay, so what we will do, we will bucketize based on the seniority. Let's see what it means. You simply click like this, and then you make the pivot, Alt D P and Alt F, and simply right click, and then we say display, and then we say classic pivot, and we say okay. This was the preliminary thing that we were doing last time also. Now the most interesting thing, what we are going to do, we can see that my tenure has also come here. So what I will do, I will simply bring my tenure, and then what I will do, I will actually bring how many number of employees. So definitely this is my employee database. So this employee ID will be unique and distinct. So if I just take count of employees, so it gives me that these are the employee numbers. So I want to present this in a different way. So what I will do, I will group this particular data. See, grouping is so easy and so simple. So if you just do this particular thing, so there are multiple ways of grouping. So if I just right click here and say group, now it is taking the minimum and maximum value. I'm not happy with the minimum and maximum value. So you simply say, let's say 0 as the maximum, and let's say ending at 10. Fine. So, and I know that I will just group it by 2. So I need 5 divisions actually. Instead of 4, I need 5 divisions. And I just wanted to see how my data will look like. The moment I say okay, see what happens. It shows me 2 to 3 years, 13 people are there, and 4 to 5 years, 11 people are there. So directly based on the year, I have gathered this particular data. If I go to my employee master, and if I do some other types of divisions also, let's say instead of year, if we do it for month, so then also we can get a very good output over here. So let's say I remove this seniority directly, and whatever is my output of today minus this particular data, look here carefully. So I will remove the year. So I know that if you remove the year, this will be nothing but the days. With the days, if I just divide it by 30, it gives me months. So if I press enter, and if I just take it as a whole number, And if I just put it like this, so I can see that this is my number of months. So this person has worked for 21 months, 67 months, 31 months, something like this. If you come to this and if you refresh this, so now there is some problem with this particular bucket. So what we will do, we will go back to our group, and we had said starting at 0 and ending at 10. So that's why it is giving. Everyone is more than 10 now because it's a month. So what we will do, we will say here the starting as 50 and the ending as, let's say, we can say, or the starting as 20 and the ending as 50. So I wanted to check this one, and my grouping should be based on 10 months. So the moment I say okay, look at this. 20 to 30 months, 7 people have that tenuity between 20 to 30 months. 30 to 40 months, 40 to 50 months, and there are 7 people who are greater than, who have tenuity of greater than 50 months. So this is how instantly you can bucketize your data. So this is not only for what we say the age, or that is not only for, let's say, hiring data or something. You can do it for anything. I'm just giving you some examples. Let's take an example. You have a huge database of tickets that are lying in the system. Fine. And you want to do some age analysis. So how long? Because if you say that, okay, I have to focus on the tickets and reduce the number of tickets. So that is a usual practice in any one of the organizations. So everyone, any service industry, or for that matter, any sales and other places also, they work on tickets. So how many tickets were raised and how many tickets have been worked for. So that is the ticket to resolution ratio and so many other things that they make. Now they wanted to make a bucketization that which tickets are to be followed. Now, definitely the older tickets are to be followed. Now, how they find out what is older? So for that, what they do, they find out the 10 what you say, the age of the ticket. So what is the age of the ticket when it was raised and what is today's date? So we will just subtract it and we will directly say this is my age, and then that basis that age we do the classification. So now what happens is, two different way of making age analysis we have seen here, which are very effective. So if you have any ideas, any queries regarding age analysis, how to do age analysis on this kind of data tickets, let me know, put it in your chat window. I'm monitoring the chat window. I will let you know how. And if I'm not able to do it right away, definitely I will get back to you at your email address. So that much I will definitely do. So let's move on to the next topic, which is again a very interesting topic based on how to reduce speculation and do something called work with something called what if analysis in Excel. What is what if analysis? These are the final analysis related topics that we will be talking about in this particular module. So let's move on to, so let's take a simple, a plain Excel file to talk about these goal seek and other things. So this is my Excel file and I open it. So if you go to data, there are some options through which you can actually analyze data. So scenario manager, goal seek and data table are the three most important data analysis tool that Excel has got. So let's do some very straightforward analysis over here. So for this, let's take an example from, see, we have taken examples from different spheres of work. So this one we take examples from finance. So just a very small example, let's say of a bank loan or kind of thing. So if you talk about a loan situation, so we have something called loan amount. So we know that loan amount, okay, Then we have something called, let's make it bigger. So I'll put it like this so that you can see it properly. Loan amount, then we have something called rate. Then we have something called um, period or tenure. So whenever we talk about any loan, so these are the terms that comes into our mind. Then we have something called balance, and then we have something called EMI. So these are the terms actually whenever we talk about any kind of loan or any bank related things. Tenure only we will put. Now they have some similar kind of terms in Excel. Loan is actually termed as PV. PV stands for principal value or present value. Rate is known as rate. Tenure is known as N per or number of, or you can say period or N per period. PER stands for period. Balance is termed as FV in terms of Excel. FV stands for future value. And EMI stands for PMT, means payment. So these are the terms that are maintained in Excel. So let's understand some scenarios. So let's take an example that you have taken a loan of 1 lakh from a bank at the rate of, let's say, 6%. So 6% we have to do some calculation. 6% is per annum, suppose. So 6% per annum means how much it will be per year. So it will be 6 by this. So 0.005. So rate will be 0.005. And tenure, let's say I want to take a loan for 36 months. So everything is in months, you can see. Why? Because EMI is in months. So EMI stands for equated monthly installment. So that's why EMI is in months. So everything has to be in months. And the balance is something that we say that at the end of my tenurity, it means if you have taken a loan of 1 lakh, at the end of 36 months, there should not be any balance with the bank. So balance should be always zero with the bank if you are taking a loan. So if this is the scenario, what will be my EMI? So the function is very simple. Function is PMT and we have rate, comma, we have N per, which means tenure, present value, which is the loan amount, and future value. Type is not required. Type is related to guess and inflation, something like this. So we are not, that is constant. So 5% we take it. So that is there. So the moment we press enter, we see that it comes up with a number. So it gives us a number 3042. This means if you take a loan of 1 lakh for 3 years at a rate of 6% interest, you are liable to pay 3042 rupees per month to the bank. So this calculates all the compound interest and then reducing balance and all those things it calculates. Okay, so EMI, PMT function. So now there are certain things we have to understand over here. First of all, just understand why this red color mark is there. This red color is there, which denotes, this red color denotes that this number is in negative. So red color and bracket denotes that the number is in finance term, anything if it is negative should be written as red color and in bracket. We don't say minus anywhere. Fine. So similarly for this amount also. Now we don't want to show this dollar, let's say. So we can right click and say format cells and we can remove the dollar sign. So if you come to this particular format cells, you can see how this negative signs are coming, how these financial terms are coming. So you can simply say like this. Now what happens? We want to do some like analysis over there. So these are my known terms. This is known, this is known, this is known, and this one is known, and we could find out the EMI over here. Now we have to understand why this is negative first of all. So understand from bank's perspective, if the loan that you have taken from bank is positive for you, then whatever you pay back to the bank will be negative for you. Just for instance, if you make this as negative, this means whatever you have taken from bank, you treat that as negative, then your EMI becomes positive. So this is how the loan amount works. Now let's do some activity to reduce the speculation. So I just wanted to check, like, if I take a loan of 2 months, sorry, 2 lakh rupees, then what will be my EMI? If I so 2 lakh is just double. So let's say, but if I say 1,75,000 rupees, if I take, what will be my EMI? I have to recalculate, right? So without recalculation, there is another method which you can just see on your screen how it will look like. So what you need to do, just take your cursor to a formula. Believe me, it should be a formula. So you take your cursor to a formula and go to data and go to what if analysis and say goal seek. The moment you open goal seek, so this is the simplest example of goal seek. It is asking for set value to value. So what is set value? Set value is saying that, okay, first of all, the cursor should be in your formula, then only your goal seek will work. So understand one scenario. I'm saying that instead of 1 lakh rupees, if I take 2 lakh rupees, and if my rate of interest and tenuity remains same, then what will be my EMI? So I'm saying that change my EMI based on this particular cell. So set the cell, sorry, set this particular cell. So to an example, let's say I'm just saying, because I don't have a formula over here, so it has to be a formula. So that's why always we have to talk about this EMI only. So let's take an example that I want to check if I can pay 5,000 as EMI, what will be the loan amount that I'm eligible for? This is the opposite way of thinking it. So I save to 5,000, and by changing cell, I click here. This is my changing cell and say OK. The moment I say OK, it calculates. And it says that if your target value is 5,000, this means instead of 3,000, if you can pay 5,000, you can always take a loan of 1,64,000 like this. If I say OK, then this value will be changed and the EMI will also be changed. If I am not happy, I say cancel. I now say that, okay, I want to, I have a, like, I want to see if I can pay an EMI of 5,000 and I still want to take a 1 lakh loan itself, how fast I can close this particular loan. So what I can say, I can simply click on here. This is the tenuity. So I'm saying that instead of 3,000, if I pay 5,000 as my EMI, then, and if I have taken a loan of 1 lakh itself, then how fast I can, so definitely my tenure will be lesser. So how fast I can recover this particular loan. So if I say OK, automatically it calculates. So these are multiple situations. So either you can check this particular option, or you can check this particular option, or you can check other things as well. So now what it is saying, if you take a loan of 1 lakh and if you want to close it earlier, and if you pay a greater EMI and for 5,000, you are likely to cover this particular loan within 21 months. So this is something, some very important speculations that we can reduce and get the answers. There are multiple things that we can do. We can take a function over here. So I say that my EMI is, let's say, 5,000. So I will copy the format here and copy the format here as well. And then I wanted to find out the loan amount, thinking that the rate of interest will be same and period is also same, and balance also I want it to be 0. So if I want to find out the loan amount, if I pay 5,000 as EMI, so I have to use a function called PV. So that is what we were talking about earlier. So PV It asks for rate. So this is my rate. It is asking for NPER. It is asking for payment, how much payment you will give. And it is asking for future value, which is always 0. And press enter. So you can see that if you pay a 5,000 EMI, so 1,64. So now you can do that analysis. So what you can do, if you go to data and you say what if analysis and you say goal seek and you say that, okay, I want to take a loan of not 1,64. I want to take a loan of 3 lakhs. 3 lakhs. And I want to see how will be my EMI. So I say this is my EMI. Say okay. So it automatically calculates. So it says that if you want to take a loan of 3 lakhs, then this will be your EMI, almost 9,000. So just an idea is you say that okay. I say okay. So automatically what will happen? This data will be punched over here. So the value will be changed. Automatically your loan amount will also be changed. So this is what GoalSeek is. So it can be used for many different places. Related to GoalSeek, there is one more option called Scenario Manager. Whatever we were doing here, Scenario 1, Scenario 2, Scenario 3, these all things can be actually worked out on a scenario basis. So let me show you something. So before going to the scenario, let me show you a tip. Let's say these are some numbers and these are the headings for these numbers. So immediately, if you just wanted to change the name, so you want to put some names for these amounts or for these numbers. So you want the name range to be there. So I want that instead of 1 lakh, it should be called as loan amount. Instead of 0.05, it should be talked as rate. If I want to do that, instantly it can be done. So now, right now you can see that if I click here, it says C3, C4, C5, something like this. Now, if I highlight this data and if I go to formulas, there is an option called create from selection, name create from selection. This is a wonderful thing that I like it. So you say create from selection. And then it says it automatically understands that the left hand side are some names and the right hand side is your numbers. The moment it says left column, the moment you say okay, see what happens. This particular cell will now called as loan amount. This will be called as rate, tenure, balance, and EMI. See how beautiful this is looking like. So it has, so instantly you have given the names to these particular cells. Now, what is the objective? The objective is to make a scenario out of this. So scenario can be done using the option data. It is similar to GoalSeek. Let me tell you, it is similar to GoalSeek. You go to what if analysis, you say scenario manager. The same thing, whatever we have done in GoalSeek, that can be added. So I say, I can add multiple scenarios. So let's say the first scenario is, if I just put it as a name, scene 1. Scene 1. I say that by changing cell. So I want the changing cell not to be this one. I say that, okay, instead of 1 lakh, I want to change it to 2 lakhs. So I say changing cell should be this one. The moment I say, okay, it is asking for what you want the loan amount to be. So I want the loan amount to be 2 lakh. And I say add. So this is my first scenario. It again asks for second scenario, scene number 2. So I say this time I want my changes to be shown in this tenure instead of the loan amount. And then it says that, okay, how much you want the tenure to be. So I say that if I put it as 24, then what will happen? So, okay. So what happens? Scenario manager adds these two scenarios, scene 1 and scene 2. Now, whatever we were doing it here, like individually, we were just going to each and every column and then putting up this formula. Instead of doing that, what you can do, we can simply click on the word summary, the option summary, and see what happens. It says scenario based on which cell. I say this is my formula. Based on this particular cell, show me the EMI for these two scenarios. If my loan amount gets to 2 lakh, what will happen? or if my tenuity comes back to 24 months, then what will happen? Two scenarios are there. Tell me what will be the output. And it asks for where is your scenario result that is based on. I said this is my cell. The moment I say okay, it shows me another sheet, a wonderful thing. So it shows that this is your current values and this is scene one, this is scene two. So what happens if you change your loan amount? So you can see the grayed out part which is changed. So if from 1 lakh, if you change it to 2 lakh, then what will be the effect in EMI? That is one thing. And if you talk about the loan amount, if it is constant and if you reduce the tenure, then what will happen to your EMI? That is also displayed over here. So you can see this loan amount, tenure and EMI, these words are not cached automatically. This is only basis the cell addresses. If you don't put the cell addresses as names, then it will come as C3, C4, C5. We had changed it to our names. That's why it is coming as loan amount, tenure and EMI. So see, this is a very small, sweet and small example of how scenario manager can be used to get. I'm just giving you an idea of how you can also work with this scenario. So let's take an example that we have a situation of our monthly budget. Fine. So we have some monthly budget. So we are spending on rent or EMI, we are spending on food, clothing, or let's say school fees or transportation. So many things we are spending on monthly basis. Now what happens? I have got two changes here. One change is that the current organization where I'm working, they have offered me a promotion, which definitely counts to a hike in salary. And at the same time, I have got an offer from another company as well. Now, I want to check which one will be feasible or which offer should I take. Either should I go with my current organization and take the promotion, or shall I leave my current organization and take a new role in some new organization, which will be feasible. So in both the cases, salary will be hiked. So you can check with scenario manager both the scenarios. I'm just giving you an idea how you can do it. So let's take an example. Your monthly salary will be changing. So this is scenario one. The base scenario is that you have a X amount of salary. Now scenario one says that your salary will be changed to Y1 amount. So Y1 amount, if it is changing, so now with the change, there are some other things that are also happening. So if your promotion is there, so you will definitely look forward for let's say some more shopping you will do, some other activities that you will be doing, some going to some malls and other things. So you will be spending. So that is one scenario. And however, your transportation, everything will remain same. So then you can see how much balance is there at the end of the month. Second scenario is when you go to another company and your salary becomes Y1, let's say. Y2, let's say this is Y1, this is Y2. So you want to compare Y1 and Y2, the scenarios. So this is scenario number, next scenario, which is having, now what happens in the second scenario, certain things will change. Let's say this particular company that you are opting for is almost around 30 kilometers far from this particular place. So now there are options. So either you will take a rent near to that particular company or you have to travel. So if you travel, your traveling cost will go high. If you take another rent, your rent cost will also might go high or it will change. So you can talk about both the scenarios and see side by side if you keep, then if this changes, then what will be my balance at the end of the month? So which is more beneficial for me? Taking a promotion in the current organization or taking a new role in some other organization? So this is just a glimpse of idea of how scenario manager can help you and work in your day-to-day capabilities or day-to-day capacities. So scenario manager. The third option is also a very useful and beneficial option. The third option is related to data table. This is also a very good example and very useful thing. So let me show you what is data table. Now let's say you must have seen that whenever you go for a personal loan or a car loan, or even if you go to some LIC agent or life insurance or other agents and other places, they show you something called a chart, that if you take this loan for this many months, then this will be your EMI. Or if you opt for this particular policy, then for this many years, this will be your premium. So they have a ready-made chart you must have seen in any one of these scenarios. So we are now going to create such kind of scenario over here. So now our component EMI is variable over here. So what I'm going to do, I just wanted to create a table. The table should look like this. If you say 1 lakh and 1 lakh, or let's say 2 lakh. So something like this. I want to make a table from 1 lakh to 10 lakh. So like this. And I wanted to show you that if the tenuity changes, what will be the effect. So 12, then 18. So, or let's say 12, 24. So 36, 48, or you can say 12, 18, 36, 34, 42, 48, something like this. Okay. So this makes a small table. So I want to populate the EMIs over here. So what is the step? So first step is that this particular corner, the meeting point of the column and row, should be a formula. The formula is what? The formula is your EMI. So if you simply say equal to this particular formula and press enter, so you can see that this particular option comes here and you have the number out here. So this is our pivot actually. This is the point. Now to make a data table, first of all, what you have to do, we have to actually select this particular table. And then we need some speculation reduction to be done here. So what we will do, have selected that table and we go to data and we go to data analysis, we go to data table. See how simple it is. It takes only two parameters, row input, column input. So row input is this one. So this way, if you move, what is there? Tenuity. This way. And this way, if you move, means column wise, if you move, then what is there? So this is your loan amount. So what you will do for row input, I will say this is my row input. And for column input, this is my column input. If you simply say OK, you see that your EMIs have come. So if you think that what is this minus minus everywhere, so let me make you understand these are all the negative numbers because they are all borrowed. So from bank. So EMIs if you are saying. So you can see that if you say that, okay, if your so you can simply say here 36 months and 1 lakh. So this is the output. So if you highlight this one, so you can see that all your outputs, so your outputs are absolutely perfect. So you can see here this number. So if this is correct, this means the entire table is correct. So this is an example of data table. So instantly we can create a data table in Excel using these particular features. So these are the important aspects of data analysis that Excel has to offer. So we will just save this particular file somewhere. So I just put it as the name my data. So these are the topics mainly related to analysis. So any queries that you have related to analysis or related to the forecasting or other analysis that we have done today. So any issues or queries that you have related to the topics, please let me know. We are just left out with one simple demonstration of analysis. Again, this module is completely focused on analysis. So we'll just have a look at that as well. So any queries, any issues, just put it in your chat window. I'm monitoring this chat window basically. Okay, so let's move on to the final bit. The final section, I can just take any data point to explain it to you. Let's say I take this employee data. So if you take this employee data, or let's take this customer sales, this will be a good data. So I will explain what is this customer sales all about. So this is a data from a particular vendor who is dealing with different customers. So there are some customers, there are some product lines that they are maintaining. They have some salesperson. They deal with some sales range as well, some order date, sales, cost, and financial year. And all these things are there, sales month, which month they have recorded the sales, and quarter and channel partners. All these things are there. So now I just want to do some preliminary analysis. So do the analysis without even making the pivot and other things. Excel allows you to do some quick analysis. See here. If you select the entire table and if you take your cursor to the corner of this particular table, the right hand side corner, you will see something very interesting. It says quick analysis. So all this while we were working with different analytics tools and other things. Now this one is an instant one. So directly without going to pivots or making charts and all these things, we can simply say, and we can leverage the power of Excel, which is in the form of quick analysis. The moment we click on quick analysis, it is showing me there are 4 or 5 different options over here. So formatting related, charts related, totals related, tables related, and spark lines related. So 4 or 5 options are there. So I just wanted to leverage the charts option. So if I simply say charts, so there are different charts. So I don't have to bother about what chart should be suitable. So if I just say, can you show me a line chart? So automatically it understands that a line chart can be made for cost by sales month. So automatically by month, it has created a cost chart. I say that I need a clustered column chart. Can you show me what type of data should be suitable for clustered column? So immediately it says that, okay, region wise data, if you want to select, then that would be best suited for this clustered column chart. I say clustered bar chart. So clustered bar chart, it says customer wise, if you want to make a chart, then the clustered bar chart will be the best suited one. I say, can you show me some relation? So line, clustered column, and there are some more charts. So these are some visualization techniques that we can do instantly on this particular data. Then I say totals. So I said that, can you show me the sum? So instantly it shows me the sum. So wherever sum is possible, it shows me the sum. Average, it shows. count it shows, total it shows, running total it shows, and some of the columns, some of the rows and some of the columns, both the things are there. Then I say that, can you show me something based on table, some pivot table? So what pivot table should be suitable? So instantly it shows me some pivot tables. It says that cost, some cost, you can put it as a pivot table. Then these pivot tables, sum of sales, and then see how instantly it is preparing the chart. So this is a very useful tool for beginners to understand what is analysis. So you take up any data. So for any kind of data, if you are just, you don't find what is the way to start analysis for this data, then this analysis technique and tool can give you a heads up directly. So just rely on the outputs of this analysis. It will show you the direction that how you should do your analysis on your data. So this is quick analysis. If you just highlight any data and you just go to quick analysis, it will show you all the possible things. So if you say formatting, I want to see conditional formatting. So automatically it says conditional color scale and icon sets and greater than, top 10. So those all data bars. So everything you can just focus on for this particular data. So instantly you can see how our numbers and data points are looking like. So charts, totals, tables, even spark lines are also there. So it can show you the spark line, whatever feasible spark lines are there. In our case, spark lines are not feasible. So that is absolutely there. So these are the topics that we wanted to discuss as a part of our fifth module. So how do we do quick analysis and how do we reduce speculation using what if analysis tools, goal seek, data table, and scenario manager. So this completes the module 5 of our Excel, whatever modules we have thought of taking. So any queries that you have, the next module that we are going to take up at 3 p.m. today would be again a very interesting one. So it will be based on macros and how do we record macros, what are the benefits. You can see, and then you can try to do some automation stuff also with macros, so which will be a very useful option and useful technique to understand for Excel. So Excel actually allows recording and coding of macros as well. So that will be the final module of our course or training program.